Let's consider there is a unknown data point u, and we want to find out categorize it. We want to find out should it be in the positive side or in the negative side. So if let's say the unknown data point is here, and so we connect it with the origin with a vector. So this is, let's say its unknown is u. So how we find out whether it's should go to the other side of the road or this side of the road? That means to the positive sample or to the negative sample. So what do? We take a projection of this vector on W, like all this thing we have studied so far. Projection is nothing but a dot product. So we make a u dot W, and if u dot W, the projection goes over this, above and beyond this, decision boundary, then we say this is a positive sample. So u dot X, so we have written, we take a projection of u on W, which is u dot W. So if u dot W equal to some constant c, and so let's say this is the constant. So this part, the decision boundary up to the decision boundary. If it's beyond the decision boundary, then we can say it's a positive sample. If it's on the other side of the decision boundary, this side, then we say it's a negative sample. So we can write it like this: if u dot W equal to c, the point is on the decision boundary. If u dot W greater than c, it's a positive sample. Otherwise, it's a negative sample. Okay. So if we combine them, so we can write u dot W minus c greater than equal to 0. Okay, combining the previous equations. And now if we represent minus c with a b, we will find u dot W plus b greater than equal to 0. Okay, so now this is, you have to remember that this is also the equation of the hyperplane. Okay, u dot W plus b equal to 0. So now this is to separate between the positive and negative samples. We can say that this W dot X positive, that means a positive sample, that means a sample which is on the positive side, and plus b greater than equal to 1. So 1 this is this line. Okay, this is just a different way of saying Wx minus b equal to 1. So Wx plus b equal to 1. So whatever you say, this line or above, then it's a positive sample. And similarly, this line or below is a negative sample. So this is exactly what's written here. If Wx negative sample plus b less than equal to minus 1, then it's a negative sample. So now we have to carry this decision rules all the time, but instead of two equations, it's always easier to carry one equation. So for mathematical convenience, what we said, we multiplied this with another variable, which is yi, to generalize x positive and x negative with a xi. So what we did, we said that yi equal to 1 for positive samples and yi equal to minus 1 for negative samples. So what do we do now? If we multiply with yi, when yi is positive, then this equation just becomes xi dot W plus b greater than equal to 1. Okay, so because yi equal to 1. But for negative sample, what happens? This is multiplied with minus 1 because yi equal to minus 1. So minus 1 times this greater than equal to 1 means by the rule of inequality, xi dot W plus b less than equal to minus 1. Okay, so that becomes the second equation. So yi is a common variable which transfers or combines these two equations into one single equation. Now just for representation, if we bring the minus 1 this side, this becomes greater than equal to 0. So this equation basically, if when there is a equal to 0, means the point is on the gutter, or this red lines, this side or this side. Okay, so what is the meaning of that? That means these are basically those points. If you remember, we call them the support vectors. Okay, we want when it's equal to 0. So we want them to be easily classified as the positive or negative samples. That's why this difference, the margin of this between these two red lines, or the width of this street, which are marked by the two red lines, we want to make it bigger and bigger. So this is it's a maximizing the width, and it's a convex optimization problem which I'll be introducing soon. What we want to do now, we want to see the difference between two vectors, which is one of them is on the negative side and one of them is the positive side of the samples. Okay, we have drawn this blue line, which is to the support vector, which is on the gutter or on the border of this highway. On the negative side, which is x minus, and this black line goes to another one, which is x plus, which is a vector pointing to a sample which is on the plus side, and the vector difference between these two is through the purple line, x plus minus x minus. There's a vector subtraction, and we want to maximize that gap. Okay, x plus minus x minus, which is the which is the width of that strip and or the margin, and we will be calculating that one using the formulation we have done here. To find the shortest distance between these two support vectors, x plus and x minus, which is represented as a x plus minus x minus, that vector. Now we want to project that on the vector w, which is the perpendicular to the hyperplane, and then find the distance. I mean, its actual magnitude we are trying to find out. Okay. So just to remind one more time, this combined, the decision equation or the decision rule, yi times xi dot w plus b greater than equal to 1, which is a combination of the two equations we got for the two sides of the hyperplane. And if yi equal to 1, then it's for a positive sample, and if yi equal to minus 1, it's for negative samples. We did it for the mathematical convenience. Now let's come to this. So when we are trying to find the projection, what we do, that vector x plus minus x minus, which is x plus stands for the positive sample, which is a support vector as well, that means on the gutter line, and x minus is another sample, which is a negative sample for the negative classes, and on the gutter on this side. Okay, so this is x minus, that is x plus. Now when we take the projection, so projection is nothing but a dot product. Okay, we have already talked about it. So this vector is projected on the perpendicular to the hyperplane vector, but we don't need the whole magnitude of this vector. Okay, so we just need the direction, because this can be a very long vector. We don't care really about its magnitude. What we care is the projection in that direction. Okay, so I need only the direction. So go for the unit vector. How we find the unit vector of a particular vector? We just divide that vector with its own magnitude, then we get a unit vector, that means a vector of magnitude 1, but in that direction. So just to explain it, let's give an example. Let's say you want to go from let's say Oxford to Dayton. Okay, so that's, let's say, 30 mile and 15 mile over the interstate 75, and you go let's say north. Okay, so the direction is north, and you have your, for own journey, you have a distance of, let's say, 15 mile, which you are trying to project on the 75. It's just an allegory. Okay, but the 75 vector itself is like the w, and it can be very long. Okay, 75 interstate 75 is like 1800 mile long, which starts from the upper peninsula in Michigan and goes to the Miami in Florida. You don't need to consider the whole magnitude. You just need the direction. I have to go north on that vector or on that line. So we just care for the direction. It's very similar to that. We don't need care for the whole magnitude. This magnitude matters to me, but not this magnitude, but just the direction matters. Okay, so that's why you get the direction by dividing the vector with its magnitude. Now this becomes a simple algebra: x plus times w prime and x minus times w prime. And then we say that for positive sample, from that equation, the decision rule, what we call, so we get that, okay, if it's a positive sample, then for y, we put 1, and then we calculate this, and equal to 1 this side. So we get that x plus dot w equal to 1 minus b. Okay, and similarly from the other equation, we get, when for the negative sample, we get x minus, which is the negative sample, we multiply with minus 1, we get x minus dot w equal to minus b minus 1. Now we take these two values, this one, and replace on this equation. And when we do the simple algebra, we find it's become 2 divided by w. Okay, this is the 2 is basically the length, this distance. Okay, there's a margin, and we call it 2d, or you can just call it a capital D, or some way. Is the distance between the two gutters, that means the width of that street. That's what is important to us to find out.